Hello children, welcome to this segment of the program. It is time for mathematics, and that means it is time to have some fun. Hi, I'm Uncle Agbaje. Today in mathematics, we'll be doing something quite different. We will be examining the concept of polygons. But before that, a correction to our last homework. We're asked to find the missing angles. Here, M is 42, because when we had 60, 78, and 42, we'll get 180 degrees, which is the sum of all angles in a triangle. In the second diagram, we have to find 3 missing angles. So we begin by doing the ones we know. And we know that this is a semicircular angle, which should give us 180. And now N is 62, because 62 plus 118 gives us 180. If N is 62, this is an isosceles triangle. E will also be 62. Now you have 62, 62. The last one has to be 56. 56 plus 62 plus another 62 gives you 180 degrees in the triangle. And final one, we're to find X and Y. And for this interior angle here, Y, it is 58 degrees. That's where we begin, because when you add 58 to 122, which is the exterior angle, you get 180, the semicircular angle. Now this is 58 and this is 68. Automatically this one becomes 54 degrees, because when you add these 3 together, 54 plus 58 plus 68, you get 180 degrees. I believe you got that right, and you deserve that share. Now moving on to today's topic. What are our objectives for today? By the end of this lesson, you should be able to name polygons that have up to 8 sides, from 3, 4, 5, 6, all the way up to 8, and then you should be able to tell us some of the properties of these polygons. Now, properties of polygons are not what you should be scared of. They are just what you can observe and what you can see, so you do not need to cram them, my friend. Let's move on. What are polygons to begin with? Any shape that is flat, any shape that is fully closed, and the sides are straight, that is what we call polygons. I'll take that again. Any shape that is flat with straight sides that are fully closed, then that is what we call a polygon. For instance, all these shapes are polygons. You see that the sides are straight. These are just some common polygons. Let's move on. Now, this is a polygon. It is flat, as you can see. The sides are straight lines, and they are closed. So, but this one is not a polygon. Why? Even though it is closed, it has curved sides. It is not straight. It's like a moon, or a half moon, sort of. Now this one, even though it has straight sides, it is not fully closed up, so it is not a polygon. So this is a polygon, this is not. It has curved sides. This is not, it is not closed. So for a shape to be a polygon, it has to satisfy 3 conditions there. It must be flat, the sides must be straight, and it must be fully closed. Let's move on. Now, polygons usually begin with 3 sides. 3-sided polygons, you know them. They are triangles. They are of different types, which you have learnt before. You have the equilateral triangle, you have the isosceles triangle, you have the scaling triangles, you have the right-angled triangle. So generally, all polygons that have 3 sides are called triangle. It means 3 sides, 3 angles. Let's move on. Polygons with 4 sides, I've told you they are called quadrangles or quadrilaterals. It has 4 sides, 1, 2, 3, 4, all of them you can see. They also have 4 angles each, so we call them quadrangles or quadrilaterals. Quadri here means 4, not the quadri in your neighbor's house. No, quadri in mathematics means 4. Quadrangle, 4 angle, quadrilateral, 4 sides. Let's move on. Now, some polygons are called regular polygons. A polygon is regular if all the straight sides are of the same length. It has equal sides all through. Also, the angles must be equal. I'll take that again. For a polygon to be regular, the sides must be the same, the angles must be the same. For a polygon that does not satisfy that first condition, then it is an irregular polygon, because all the sides will be of unequal length and the angles may not be of the same side. Let's look at some regular polygons and some irregular polygons. This is a regular triangle. All the sides are equal. It's a regular triangle. And of course, that's the equilateral triangle. All the sides are equal and all the angles are equal. But this is another triangle. You can see that this side is shorter than this side and that side. So that is an irregular triangle. It's still a triangle, just not a regular one. All right, we'll move on. So a regular quadrilateral has all the sides equal and all the angles equal. That's why this is square. A rhombus has all the sides equal, but all the angles are not equal, so it is not regular. For it to be regular, all the sides have to be equal, all the angles have to be equal. So this is an irregular quadrilateral. 4 sides and 5 sides. 5-sided polygons are called pentagons. We'll still come up to that. This is regular and this is not regular. The next one is 6 sides. 6-sided polygons are called hexagon. Do not fret, my friend, we're still coming back to that. 7-sided are called heptagon, and this is a regular one. This is not a regular one. Some sides are longer. And this is an 8-sided polygon. It has all 8 sides equal, and that's regular. But this one, not regular. As you can see, this side is shorter than this side. So this is not regular. We call it irregular octagon in this case. So moving on, we're now going to look at the properties of polygons. What are the things that we can observe about a polygon? Like I've said earlier, when you're asked to talk about properties, you do not need to be scared. Just look at that polygon and write what you can see. And perhaps at the end of this lesson, you will be able to discover some observable features of some polygons. Let's move right to it. We'll be looking at the properties of polygons under these headings. We'll look at the number of sides it has. We will name it. Then we'll look at the line of symmetry. A line of symmetry, as you may recall, is a line that divides a shape into 2 equal parts such that you can fold it along that line and they will be exactly on top of each other. And then we want to see how many triangles you can find in that polygon. We will begin. This is a triangle. It has 1, 2, 3 sides that are closed. So the number of sides is 3. And we call this shape, of course, we call it a triangle. But how many lines of symmetry does it have? We're talking about regular polygons. All the sides must be equal, mind you. Regular polygons, all the sides must be equal. So how many lines of symmetry? Now let's see. Go. We have 1, 2, and 3. Again, 1, 2, and 3. These lines divide the triangle exactly into 2 equal parts. You can fold it along this line, you have 2 parts. You can fold it along this other line here, you have 2 parts. From the angle on top downwards to the side opposite it, you can fold it and you will have 2 equal parts. Moving on, it has 3 lines of symmetry. Moving on, let's see the next shape. This shape has 4 sides that are equal. So write 4 here. Now, since the 4 sides are equal, it's a quadrilateral, but since the 4 sides are equal, that is a square, my friend. But how many lines of symmetry does it have? There should be one that divides it here, one that divides it here. But it also has 1 here and 1 here. Let's see all the lines of symmetry now. Say 1, 2, 3, and 4. These are the 4 lines of symmetry. You can take a square shape in your house and fold it along these lines. You will discover that they will fold exactly on top of each other. It will be equal. Moving on. Now this is where you need to pay attention. No need to cram all these names. Just know them. This shape has 5 sides. 1, 2, 3, 4, 5. And so we'll put 5 under number of sides. It's 5. But what is the name? We'll call it a pentagon. Say pentagon, everyone. Pentagon. This is one name you have to put at the back of your head. When you hear pentagon, it means a shape with 5 sides. Now, this is a regular pentagon, which means that all the sides are equal. But how many lines of symmetry does it have? I'll show it to you. From the top here, I can divide it downwards. And then from here, I can divide it this way. It will be equal. And then it will be equal here. And it will be equal here. So 1, 2, 3, 4, 5. Wow. It has 5 lines of symmetry. Oh, wait. I'll put 5 here. But do you see what I'm saying? Let's zoom in on this table now. So this shape, a triangle, has 3 sides and 3 lines of symmetry. Now, a square has 4 sides and 4 sides of symmetry. A pentagon has 5 sides and 5 lines of symmetry. Are you seeing what I'm saying? Let's move on to the next shape. The next shape should have 6 sides. Let's go. 1, 2, 3, 4, 5, 6. Of course, it has 6 sides. But what do we call this shape? It has another name that you must put at the back of your mind, and that is hexagon. We'll call it hexagon. When you remember 6, x in 6, x in hexagon. Now, do you want to guess how many lines of symmetry it's going to have? I want you to guess. Are you guessing what I'm guessing? Because I'm guessing 6. Let's go. 1, 2, 3, 4, 5, 6. Wow, 6 lines of symmetry. So you see, we've discovered a way of getting the number of symmetry that a regular polygon has. I'm going to guess that the next one, if it has 7 sides, then the line of symmetry will probably also be 7. But let's check it out. Next shape, please. This shape has, starting from the top, 1, 2, 3, 4, 5, 6, 7 sides, of course. And this shape, we'll call it a name you have to put at the back of your head. It is called an heptagon. Heptagon. Now, as to that line of symmetry, we're saying it has 7. Are you thinking it has 7? Let us see it. 1, 2, 3, 4, 5, 6, and finally 7. So it has 7 lines of symmetry. Now for the final one, let's see the next shape. Should have 8 sides, starting from the top. 1, 2, 3, 4, 5, 6, 7, and 8. So it has 8 sides. I put it on the number of sides. But what do we call this shape? A name to put to head. We call it an octagon. Say it after me. Octagon. Octagon. Good job, you. But how many lines of symmetry does it have? Your guess is as good as mine. It's going to have 8. So let's count. 1, 2, 3, 4, 5, 6, 7, 8 lines of symmetry. Wow, this is so easy. I mean, if I know the number of sides, automatically I will know the number of symmetry lines that a regular polygon has. So before we move on, I'll just run you through the names again. 3 sides, of course, you know, is a triangle. 4 sides, of course, you know, is a square. 5 sides, of course, you know, is a pentagon, in that you have to put that at the back of your head. Pentagon. Say it after me. Pentagon. Hexagon. Heptagon. Octagon. Again. Pentagon. Hexagon. Heptagon. Octagon. Now, that is the end of that segment. I will go on to something more interesting. Now, by joining the corners, we want to join all the corners now without intersecting lines. We want to join the corners of the polygon without crossing any line over each other. How many triangles can be formed from each polygon? Let's go. The first one comes out. It's a triangle. This is a corner. I want to join this corner to this corner. I join the corner 1, 2, 3. I just join all the corners. And I have just one triangle. So it has just one triangle. I mean, come on. So if I know the number of sides, if 3 is 1, this is 3, and this is 1. No relationship there. Okay, so let's see the next shape. The square has 4 sides, but if I join corners without crossing lines, I can join this one to this one. Yeah, and so I end up with one triangle on this side and one triangle on this side. Okay, so this has, but if I join this side, I will be crossing lines, and I don't want to cross lines. I just want to join corners without crossing lines. It says without intersecting lines, so 1 is enough. So that means I can only form 2 triangles. So put 2 here. Let's see the pentagon now. Okay, so thank you. 1 here and 1 here. I can't join this one, and neither can I join this one because I will be crossing lines. So I'll just join 1, 2. So how many triangles do we have? 1, 2, 3. Let's go. 1, 2, 3. Oh, that's it. So I put 3 here, but a pattern is emerging already. As you can see, you have 1, 2, 3. But what is the relationship with the number of sides? I'm still thinking. Let's see the next shape. Maybe I'll get some inspiration from all this. We have an hexagon now. So how many by joining the lines? So okay, so I join this one to this, I join this to this, I join this to this. I can't join this. I can't join this way because I'll be crossing lines. So obviously, but how many triangles do I get? So 1, 2, 3, 4. Wow, it's 4. So there is a pattern emerging. So I'm going to be guessing this is going to give me 5. Okay, but what is the relationship? If I know the number of sides, will I be able to know the number of triangles inside? Let's say 3 gives me 1, 4 gives me 2, 5 gives me 3. What's the difference between these numbers? Let me say 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2. Oh my God, 6 minus 4 is also 2, which means that if I know the number of sides, I will just subtract 2 and I'll get the number of triangles. Let's see if that works for the heptagon. Bring the heptagon, please. So let's see, how many triangles can we form? All right, it's been formed for us. 1, 2, 3. Okay, so how many triangles are here? 1, 2, 3, 4, 5. Confirming our guess that we will have 5 triangles. And that means 7 minus 2 is 5. Okay? Finally, let's have the octagon. I'm going to be guessing this is 6 because 8 minus 2 is 6. But let's just be sure. Let's just be sure. So I'm just going to join the angles this way and count the number of triangles in there. Let's count with me. 1, 2, 3, 4, 5, and 6. Confirming our guess. So this is all quite easy to see. These are some of the things that is obtainable for all regular polygons. When you have the number of sides, 3, you have 3 lines of symmetry, but only 1 triangle can be formed. When you have 4 sides, you have 4 lines of symmetry, but only 2 triangles can be formed. 5 sides will give you 5 lines of symmetry, but you reduce that by 2, and you get 3 triangles inside it. So that sums it up. Let's see the summary of all that we have learned today. So if a polygon has n sides, like it has any number of sides, then it has n line of symmetry, as we have discovered. If it has 15 sides, then the lines of symmetry will be 15. But how many triangles will it have? If it has n sides, then it is made up of n minus 2 triangles. So if it has 15 sides, the triangles inside will be 15 minus 2, and that is 13. Now copy this and do them during your leisure. You have a table here. I've done the first one for you. A regular polygon has 9 sides, then it will have 9 lines of symmetry, and then, 9 minus 2 is 7 triangles in it. Complete the rest, and we'll take the correction in our next class. Now, just before I go, today is Tuesday, and I like to call it Magic Tuesday because I want to show you some piece of magic. Last time we talked about how to multiply by 11. Today we want to look at how to multiply numbers with 5. Now, when you tell children to multiply, they give you this kind of expression that I don't like, like multiply 5 times 24. I remember some times ago, I told the child, multiply 5 times 13. And he said, Uncle, there is no 5 times 13. It stops at 5 times 12. No, multiplication continues till infinitum. Now, 5 times 24, you don't need to get this expression on your face. I mean, it's a breeze, and I'll show you how. Now, how do we go about this? Half of 24 is 12. When you know that half of 24 is 12, just replace this confused expression on your face with 12 and put a 0. And that is just it. It's as simple as that. Let's take another one of the same kind. 5 times 68. Don't give me this expression. Come on, you're not a baby. Just know that half of 68 is 34. Replace your 34 with your expression and put a 0, and you have 340. But you need to know that this method only works for even numbers. Now this magic can as well work for big numbers. 5 times 4,444. You don't need to look like this guy. I mean, he doesn't seem to understand mathematics much, but you shouldn't be scared. All you have to do is follow Uncle Agbaje's little trick, and that is just take half of that. Half of 4,444 is 2222, and replace that confused expression with 2222. Then give me a 0 behind it. You have 22,220. Multiplication with 5 is just a breeze. Now I will hand you over to Uncle Popo for the general studies lesson. Till I come your way next time, remain wonderful mathemagicians.